or a non-terminus symbol to the left, or you could equally say to the right, but only on one side. So if I force that, then searching that tree and resolving that becomes much easier. And that's what the regular expressions are basically. They have limitations, because even if you have used regular expressions, you basically create a syntax or a grammar. And that, might have, if you say \d plus, that means any digit, one or more. So you actually create a recursive structure, but it has a certain form. Then there are different ways in there, and it becomes more and more complex. And it usually ended up becoming difficult because the computational complexity was just so enormous. Particularly if your parser does not allow any heuristics in there. I think today we have the opportunity, because we have access to billions of documents, and we can develop statistical or probabilistic models. Which route should I go parsing this? We probably could be doing much better already. So, yes?
I have a question as for context. You had types there. Prior to that, you had 4 examples of companies there. And if the first step in your pipeline was, I believe, lexical breaking down of paragraphs.
Oh, yeah.
But that first step, you get that complete frame of what the intent could be. If you're in your language, a paragraph or a movement is bound to that intent. And so what I'm trying to drive to is that you're looking at each sentence, but in totality, you should be taking the context of that paragraph. And if you're just looking at your frame, it's just probably focused on that sentence. I'm trying to get to,
you cannot,
how big is your frame? Do you keep the prior 1 sentence, 2 sentences, 3 sentences?
You may have to, if you document, let's say, it's an SEC filing or something.
Those are easy because I have.
They're actually fairly structured, right?
They're very structured. I have a balance sheet and income statement. So there is a text, but they could lie in the text, but I can always look at the raw.
Well, part of it is now, yes, we have the balance statements, but then there is a human reporting to it. And what you want is you want to find out if there is, because they're basically obligated to disclose things. And,
It's the bullshit on the earnings call, but the income statement is.
Yeah, I mean, the income statement. So, I heard there's still some interest in going through that, but let's say legal documents is another thing, case files. And you want to find out what when you may know your documents, you probably know whether the plaintiff won or not or something like this. But you need to go in and find out what were the criteria that actually led to this particular verdict, then to find, to search basically, does any of that apply to my case, and I can relate to that. So then it becomes really, really tricky, and it might be fairly complex. I've never done it, but I heard, people start working, or people are definitely have an interest in doing that, and I think there are some people, or some companies doing some of that to reduce the human involvement in that. But going back to this particular thing, you start, and it depends on what you want. So if you just want to see, is this a spam email? Or if you just want to classify, is this a technical document versus a advertisement or marketing or something like this? You might not have to go that deep. But you might have to go that deep if you, let's say, it's a medical document that explains a particular treatment and the outcome. And you actually want to create a representation of, was that successful, that treatment successful? And even though you usually have companies with numerical data, sometimes the text might actually reveal information that is not captured in this way. So that's basically what we want to get to.
participated in the club match. Yeah, so, right, that's where application of NLP.
Oh, yeah.
Because you want to extract that meaning from hundreds of thousands of dollars.
Right. So, next, thank you for speaking with me. You're so polite. I have a few, so I want to show you a few things in Polo, and which is a programming language that is a symbolic programming language. It's fun to play with, as it was for some and it actually has a syntax built in that kind of lends itself to develop these grammars and parse them. So there's no I/O, it's like a very awkward timing. But these are like very small programs, and I put them on GitHub. This presentation is also on GitHub, so if you feel like notching this on right now, or come back later if you can remember this, Frank might put the link on there on the Meetup site. So let me switch screens here, and yes, yeah. So yeah, they are. Yeah, sometimes some individuals might not get confused. But, I think on Windows, I mean, years back when I used Windows, had to use Windows for something. I believe you can only have one extension for a particular application. So then you have to, pick something else. If you also use Windows, you might have to use Pro or something. I'm a Unix person, that's like what it's saying to me. All right, so here's all this stuff here. Oh, here we go. So okay, so I'm going to. In the first one, I actually want to just show you a little, sort of the first hello world in Polo, and to kind of get an understanding what I'm talking about here. The language is very intuitive. It's actually inspired by first order predicate logic. So logic, propositional logic, predicate logic. Yeah, well, yeah. So, but it's actually mathematical, or even physicists, a lot of physics, what I'm saying here, philosophy students use that. So predicate logic is basically a calculus that allows you to create predicates that are either true or false. Just like we have propositions, which is like, if I drop this remote, it falls down and breaks. These are all basically propositions that might have, if certain propositions then imply a certain number of propositions to be true. So we use logical reasoning, and the predicate logic allows us to actually have these sort of propositions but add values to it. So we can think of this also as relations. So a predicate, and then it becomes the term predicate, the predicate of a sentence. I'm going to show you that in a minute. It actually, you can think of entities, and in this case again symbols, because we just represent something, and relations in there. But then we do logical inference on that. And so the beauty of this whole programming this logic is a subset of the first order predicate logic. To precise the more normal form, it doesn't only have universal quantifiers. And if you don't know what it is, that's all right. It's just fancy words. That would be little here. I could speak hours on that, but all right. So let me see if I get my. Doesn't know where I am, so I have to go all the way. I believe I have to go all the way to the. closer. All right, so the first one, hopefully remembers that for the next time. So this is actually is font big enough? So let's assume we have, this is about kinship. So our Hello World program is creating relationships. And the first thing we have in our language is we introduce a predicate, in this case parent. It's actually parent of, or is parent. And we have different symbols. So what you see actually the editor helps because it's open. So the syntax is we have a predicate and then in parentheses we might have some arguments in there. They're comma separated. So these are not functions. We don't have, Prolog has functions, but we don't need functions. We don't do functions. If this applies, then that. And so that's basically a simple example here. So let's see if this runs. What I do is I have my editor here. Control CV. Now let's put it in here. Then let's see if we find it up here. Now this is my goal window. So I have my knowledge representation here and my goal here. And now I can say, parent, what was it, Bob? Stick in here. Bob N. And it tells me, yes, that's true. So if I ask for parent Bob Max, it says that's false. It cannot find any binding for these variables for that same parent. Then if I use a rule, let's say for example, here I define father being, so we introduce conjunctions. So they're saying every x and f of every y can be a father if x is a parent of y and made x is made. So that's how we would define the father. Bob n should be true, right? Yep. And then who else is related to? N is related to nobody else. But Bob has a couple of parents. So in addition to basically stating facts here, who's the father of Bob? It's Tom. So what I did is I said who as a capital, and variable names don't care at all. The variable only exists within that clause, basically from the beginning to the period. But then, wherever, in every place how often I use that variable, it has to represent the same value. So what Prolog does, it tries to find now a value that makes my entire expression true. And that's how I write programs. So it basically has a search in there for you to get like basically doing a depth first search, which kind of can make it fairly complex. But it's an elegant way, because what we do is really we explain we don't say how things are solved, we say what's true. And this can be rules and facts. And from that building something up. So this is a nice little thing here. I'm using SWI Prolog, which is has been around for a long time. But there's also they also have a website where you can basically, I just pulled it up. It's called Swish. I think I linked, put it up there. Where you can actually play interactively in the browser with that, and you don't have to actually install the programming language.
Yeah, the Prolog package.
Yes, they actually exist. I don't think that's the editor in there, but yeah. So it's, and then you get, so actually it's a fairly complex. So you can write really complex applications. It has a rich library of all kinds of different things. So it's not just time problems. So people write real code with it. I just have one to one good project to work with. I wrote a whole web server back for my class because it was doing scheduling based on the data that I imported. So there was so many. Basically, anytime you come to something where you end up with like a billion if statements because you have so many cases, that's your gun. Because it basically, you break it down and you break it down into rules and it tries to find the right solutions. So,
How would Prolog compare on the assignment problem or scheduling to linear programming?
Well, the pure Prolog would be miserable because it uses a depth first. So, and it does a complete search. But that's just the engine that's built into Prolog. So what you use that behavior then to actually implement your algorithms. And then you can implement algorithms that also include employ heuristics. So, and you know, we have different data structures. You can actually create any type of structure because these predicates can be nested. So the argument for the element of the predicate by itself can be the predicate. And so we can create list structures from that. And it's not necessarily, there are some applications where it's actually geared towards fairly high performance. But it's not geared towards that. But it's particular to have a particular problem to really represent it in that logic and not be concerned about what the cloud actually wants to solve. But
Does it have to have a board? If you were trying to say you're doing lineage, but somewhere you can have information.
Yes. Right. Yes. I don't have anything in here. So basically, it's this is kind of. I think if Prolog came out today, they might do a Unicode or UTF on that, and you would use real symbols like you can do in Julia or something. But so the comma is a logical end, and the semicolon is a logical or. But then also we might have alternative. We go back to the other screen. We might have alternative clauses. You see, for example, I have predecessor. I have two different clauses here. And these would be different. This would be the destruction. So if one works, it's fine. If it fails, it tries to do the next one. Okay. So now this is basically, I can play and I can basically ask things like, can we get rid of this here? I want to see, let's say, predecessor, this is a recursive of anybody with anybody, and just say it's X and Y, and now it can give me all possible solutions that it finds. Yes?
So is it possible to extend
Predicate?
it's something close to fuzzy line. For example, when you assign the
Yeah. So you have numerical representation in there, and that's actually there. You can do that. It doesn't do this internally. They're actually extensions of the pure Prolog. People try different things also to basically do a probabilistic approach. So there's some interesting things, but most of the stuff is very academic. So Prolog by itself is, I think, outside the classroom in academia. There are a couple of oil companies who use it for expert systems and stuff like that. There's some proprietary implementations that have like code probably also based on legacy code. But nevertheless, so let me pull out my next one. This is just to give it like a little teaser. Can't remember which one I was supposed to do next. Oh, numbers. Let's do numbers. Good. So, and I know that these things always take longer. So So, but this I think is cool. And we can go on forever, but so this is actually what you see here, there's a little clutter. Starting this number, this is actually my language here. And so the difference is, if you think like, a grammar has production rules. And what you see here is these rules. You saw there was like a symbol, an non-terminal symbol, an arrow, and a sequence of terminal symbols. That's what we express here. Even as just one is in the list. So our terminal symbols are all lowercase symbols. Our non-terminal symbols are predicates. So the predicate always has, basically has an argument. Makes it a little bit harder to see because you could argument. You don't even have to have it. Because if you have no argument, you don't need to have. No, you still need to branches. But anyhow, so what we have is like we have digits here, and this are our so all these 1, 2, 3, 4, 5, and so on, 10, 11, 13, 24. These are all our digits, our terminal symbol. And so what I want to do is basically create a grammar that can understand if I were to spell out, let's say that would come from voice to speech to text translation. If I say 275, what that does actually mean. So, but this is basically what this one does. This grammar here, I limited to numbers up to 999. Because it gets a bit more complex there. But so I have a predicate here number, and this is a special syntax, and so there's no thrills to this here. Control C, Control V. So I compile and load it into my memory. It should be here. Unfortunately, there's no clear screen here, so it's a little bit cluttered. If I say listing number, which all right, so here's my predicate. And basically, that's the internal representation. So this is basically syntactic trigger in Prolog to say my non-terminal symbol number, which is like sentence, can be either a number 3, that's another terminal, basically 3-digit, or a number 2, 2-digit. And then I say my number 2 is something that is either a tenth and a digit, or a digit, a 10, and 2 symbols. What did I say? 275. And then this is, I want to, the last empty list is to force it to make sure that it resolves it. You see the result there? Ta-da. 275. Result, yay. My grammar does not allow to do that. Even though I could maybe think of doing that because it's quite complex to say that. I probably would be in trouble if I ever would not allow that. Okay, so get my numbers here. Okay, I've sent. So what I do is basically in Prolog, I say what's true. And I say find me a solution. So what I did actually when I submitted this variable right now, I had an n there. My n was an unknown variable. It basically says make this predicate true, and by all means find a value for n that makes this true. If I would give it a value, so for example, if I would say this, this allows me to kind of paste, no? 75. Yeah. So, oops, I think with part of, oh, I forgot it. Right. This should be false because they don't match, right? But what is the sentence? 78. So what I do here is a totally primitive grammar, but already useful. It goes both ways. The grammar can produce and it can parse. So I can give a sentence and it tells me whether the sentence is correct. And what we do in this process is not only that we parse the sentence, like I put this to NLP, I actually, while I'm parsing it and understanding where each of these positions is, I actually do a little computation to calculate the real integer value of that number. But for Prolog, finding the solution is just searching through all possible values and finding what matches, and that's what I return. So, last thing, if you can hang with me, I think that we have enough time. I found this here, fortunately, I didn't have to write it myself. Very elegant way. This is a grammar for Roman numerals. Same thing, so I call this Roman. Let's see how, we can make this a little smaller. How this comes out. So I need to go here. Okay, so I say Roman. And let's say N again. Now I did that in lowercase because otherwise I would have to use quotes. So what was the last supercode was actually just was it V1? 50, was it 50 or 51? Which one is 51? LI. What the hell is LI? 51. All right. Cool. Okay, so let's say LI is 51, but I really want to know what that is in English. I have my Roman numerals to English language translation. Machine translation in this text.
Nice.
So it's totally primitive, but using these basics and building on top of it, I think that's also, it's not completely lost. And what's really in there, and I have to, there's actually, while I'm parsing this, I can add meaning to this. There's another example in here, it's actually natural language impaired, that takes sentences and basically creates a logic structure from that. So that basically still would have this toll example, would have a good word. But if I say every human is mortal in English, and it actually understands how to represent that in a predicate logic as a data structure internally, not as just text, but as a data structure, then I could basically have plain English converting into SQL queries, or plain English converting into Prolog clauses, and then continue having these Prolog clauses reasoning on. And then I'm really like what we dreamed of when we were kids back in the days, programs that learn from themselves and become smaller and smaller. So it's all in a very much environment, but I think there's some really great ideas. Have been around for decades, but I believe there's still value in that. And so that's why I really appreciate the indulgence to kind of share it.
All right. So, all this effort, understandable, but this is really interesting because I guess it showed a proof of concept. It can, with little logic, be translated, right? Okay.